Hey, welcome everyone. We're very excited to have everyone here today to kick off our Rust on Linera hackathon hosted on DevPost. So to give you guys a brief overview of the event, first, the Linera founder Matthew, who I'm with today, will give us a presentation on the Linera protocol, followed by myself giving a short presentation on the program specifics, resources, and how to be successful in the hackathon. So with that being said, Matthew, please go ahead with the slides you've prepared.
Awesome. Hey everyone, thanks Jesse for the introduction. So I'm super excited to kick off the spring hackathon. And so thanks for everybody for being here. And I'm so today so I'm going to present the protocol in detail. So the Linera protocol has a lot of features, and so going to so of course these are documented in the developer manual, but it's always, it's super interesting to explain, also to give you some context. Always useful to give you some context and to go into some of the details of the design. So let's get into it. Okay, so Linera is a decentralized protocol, and one of the defining features that is that it's based on microchains. Microchains are parallel threads of execution that, in the end, give users their own reserved block space. So why would we want to do that? Um, well, we can start with an analogy that I like. If you have a car and it's in the middle of a parking lot that is crowded with lots of cars, and you're calling for a valet because you want to move your car, it's gonna take some time. It's gonna take some time. The valet maybe has to move some cars around, and eventually you'll be able to move your car. But it may take some time. You never know how much time it will take. Maybe you need to tip the valet a lot more if there were a lot of cars, if there was a lot of work to do today to move your car out. Okay. But now, on the other hand, if you have your own garage, um, and you want to move your car or you want to go somewhere, well, you just take the keys, open the door of the garage, and that's it. You have your car. And so Linera, we trying to we when we what we're building is trying to be in a case where you already have your reserved block space, you already have your garage, everything's ready, and anytime you want to move your assets or start the transactions, you can create a block very quickly in your using your user wallet. Um, okay, but now in the details, what does it mean? So and before that, what? Okay, so and then, but what's the vision? What's the point of doing this besides the beyond the cute analogy with cars? So by giving a blockchain to every user, so we're giving them a personal blockchain. What we want is really to give users superpowers, improve the user experience when interconnecting with the blockchain ecosystem. So we want to be really helping interoperability and generally supercharge Web3 applications. That may also be like so that would have a component into Linera to help with the user experience, and may have also components in other systems. And we really want to enable this really good user experience and bring these new features to the world of Web3. So to do that, the first problem we're trying to solve is when the user is interacting on chain, we don't want them to compete for block space. We don't want them to wait for somebody to, some valet to move their car, right? So for that, we're providing them with their own reserved block space, their own microchain. And so Linera, in a way, is a decentralized infrastructure where block space is split into an unlimited number of parallel chains. And so we're really optimizing for supporting many, and we call them microchains. So we're really optimizing for many parallel chains, as opposed to one super high TPS blockchain. And so it's not that and so we're really optimizing for something different, and we think that's a piece of infrastructure that just that doesn't exist, and it's kind of missing, and so we want to provide that to the world and interoperate with other blockchains to create the best Web3 applications. So microchains concretely, what does it how what does it look like? So we're going to have one set of validators, and each of them is validating all the chains, all the macro chains. So each validator is going to use ideas from that comes from Web two. That So internal sharding is the main idea that's really going to allow us to scale horizontally. Um, and then but then when we split the block space in many different chains, we definitely know that everything interesting is going to be cross chains. So there's going to be a lot of cross chain messages between all those parallel threads of execution. So we want an efficient cross-chain messaging system, which is something that I'm going to cover in this talk. Another thing also is if you see the remember the analogy I was giving. So also we try to give users a direct access to their own chain. So we don't want them to use a mempool to depend on block producers to pick their transaction. So we are going to provide a system where the users directly create their block. And finally, we want the highest level of security. So and that's the reason why the validators are validating all the chains with the same security. Something interesting also is to notice is that this framework, I mean, this picture is based on research that I started at Facebook many years ago. At the time, it was only a payment system called FastPay, and so tribute to the research I did then. Um, and then of course after that we strongly generalized. If you read the paper, you will not recognize Linera as much. We introduced many concepts, and the first of them is the microchain. All right, so this picture is nice. So, but okay, concretely, how is this gonna, how is it going to help us? And so the fact that we have this many chains, um, we really believe it is going to enable a new wave of Web3 applications. Um, I'm not saying it's the architecture for existing applications. For instance, Uniswap is totally fine with one single ITPS chain. What we're interested in is applications that actually do not need to share a shared state to share a state between all the users. And when you look around in Web 2, that's actually most of the applications are more naturally organized in terms of user accounts and objects. So our payment system obviously are moving money from one account to the other. Social applications let you post in your newsfeed, in your user account. Um, if you look at some aspect of some trading systems based on auctions and atomic swaps, so you could imagine the auction to be just on one object, and a few users are interacting with an auction at a time, as opposed to everybody interacting with an order book, for instance. And then finally, if you have a game instance, so like a multiplayer game, let's say the simplest one would be chess. That's an object, and there are only a few users interacting with the game at a time. And so for all those applications, our observation is that they map really well to the model of Linera that gives each user and each object their own chain. And as a result, we'll see in this presentation that the execution model of Linera will unlock much better, much faster user interactions with their on-chain data. And also, I will also, and then will also allow us to execute transactions in that would be too heavy for a traditional chain. Okay. So once again, in Linera, we have one set of validator that runs many parallel microchains. And something that I mentioned that is very important to understand is that the fact that when we say that a user owns their own chain, what it means is that they are they are the only entity, the only agent producing block in that particular chain. So all the chains are validated in the same way, when we're saying that a chain belongs to a user, what we mean is that that user um, is a sort of permanent leader that can put transactions in a block and submit the block to have it finalized. Okay. And but that's we have several types of chains. Some of them are also owned by multiple users or even the validators. All right, so that was the introduction. So now let's go into some of the details. At a high level, and so this presentation is going to be mostly about the simple case of a chain belonging to a single user. Um, and so we call them user chains. So when you have a user chain, in the simplest scenario, producing a block entails only 1.5 round trips. Um, so typically the user wallet would gather a small number of transactions into a block and would propose that block by broadcasting it in parallel to all the validators or sufficiently many validators. The validators then are expected to validate the block, and if the block is correct, sign the block and say, okay, this proposed block is valid. Send the signature back to the wallet, and then once the wallet has, or in general the user client has a quorum of signature, then you can aggregate that, and we call that a certificate, and then you can broadcast the certificate to all the validators, and that's going to effectively extend your chain. All right, so one thing to notice in that is this simple picture. There is only client to validate. The validators are not talking to each other. There's only client to validator communication or validator to client communication. So that's one of the property of Linera that we like, because it makes operational costs lower on the validator side. It's just the work of validators much simpler. And also, if a chain is not used, we're really guaranteed that it's going to be sleeping in storage and not cost anything to the validators, at least most of the time, unless there is some maintenance to do. But by default, we really want unused chains to be really low cost. Then okay, and then this is a simple picture. So we'll see that so sometimes you have more round trip. There's some synchronization involved, but in the best case scenario, the simplest scenario, that's you can create a block in 1.5 round trip, which is basically theoretical minimum. Okay, so then when it comes to the security of the network, so the nice thing about having validators that validate all the chains is that from a high level, we are running essentially a textbook proof of stake. So if we were to formalize this, we could say that so it's the normal BFT model. So validators have voting rights. You suppose that at most F voting rights belong to potentially malicious nodes, and so the important number is 2F plus 1, which gives you, as soon as you have 2F plus 1 votes for a block, we say that you have a quorum, and that makes the block satisfied. Or at least that makes the block valid. So so what's interesting is that the safety model is canonical BFT for when it comes to safety. There's no networking assumption, so it's a very strong property. And also the fact that from the point of view of security analysis, and proof of stake, this is the textbook, like I said, the textbook proof of stake, similar as a single sovereign chain. All right, so now if we look into the details of what's in the block. So in the block, we're going to have a sequence of transactions, and there are two types of transactions in here. So the first type is the operations that are added by a block producer. So when the block producer is a user, you can think about the operations as new transactions, so something that the user want to initiate. Another kind of transactions another kind of transactions is receiving a message by picking the message from the inbox of the chain. So what are these boxes? So we want chains to communicate with each other. So any transactions can create messages and send them to another chain. And naively, we could think like, okay, when I receive a message, I just execute it to modify the state of the chain. But the thing is that because the system is replicated across all the validators, we can't just do that because the validators may. So validators are going to use their internal network to carry the question messages from one chain to the other. But if you were to observe all those validators, you would see that the messages can happen at different moments and perhaps in different orders and in different ordering. So what's important is that you execute messages only when the next block arrives, when a user tells you that is the owner of the receiving chain is ready to accept a message. Only then you execute the message. All right. But other than that, the the system is relatively is you have asynchronous message when you program. You can kind of forget about this. You have asynchronous messages. You can send them to the other chain, and eventually, if everything goes well, they will be executed on the other side. Um, okay, and I'll say a few words more in detail about messaging later. So now I was just a small refinement of the picture later. So in practice, a wallet doesn't have a single microchain. In practice, a wallet wants to track several microchains at the same time. And in particular, if one microchain sends you some messages, you may want to track that microchain up to a point. So there's some work we require from web clients to synchronize the validators that may not be aware of certain blocks. So there's a little bit more traffic than in a simple initial picture. But that's all, of course, programmed and completely transparent for the developers. Also, if a chain has multiple owners, the picture with only 1.5 round trip is in fact has to be completed with one more round. So in the case of chains with multiple owners, or if there are some oracle calls in a block, then you would have 2.5 transactions, 2.5 round trips. Okay, another thing also that is worth noting is that we encourage wallets to maintain a connection to the validator so that they can receive notifications to tell them that, for instance, somebody has sent them a message. So if you have a new message in your inbox, the validators will and you're connected, and your wallet is connected. The validators will notify you so that you can synchronize your own local replica of the inboxes and the other chains and act and finally create a block to receive the message. All right, so let's go into the details of the SDK. So like I said, we have two types of transactions in a block: operations and executing operations and receiving incoming messages. And both types can create outgoing messages. And as I explained, so the messages are delivered. So it's the task of the validator implementation to deliver the question messaging exactly once. Once they are created on one end, they must be delivered exactly once on the other end and wait in the inbox of the receiving chain. Yeah, that's right, Danny. If there are any questions, I'm happy to also take them even during the presentation if I see them. So now when it comes to composing applications and programming applications, what's happening is that you have a new block that can have, like I said, two types of transactions. And in the state of the chain, you may have a number of applications that have been deployed, and they have a state. And now when you have a transaction, it's going to call into that state and perhaps modify it. What can happen is also that an application wants to call another application. In that case, the call is blocking. And so the composition of application inside the chain is very much like on the surface, at least, is very much like Ethereum or many blockchains. You have like composability inside the chain, arbitrary composability between applications inside one of the inside the macro chain. How do you create applications? You create applications by writing them in Rust and compiling them to wasm bytecode, and then publishing the application on your own microchain, and then the system will make that available to all microchains. The Okay, so now the what's important to notice is that operations are kind of like public APIs of an application. So any block can create a new operation that is signed by the owner of the chain, can create a new operation that will be executed by the application. When an application creates an outgoing message to be delivered to another chain, the receiver, the code that will eventually execute that message is actually the same application. So in a way, messages are internal to an application, and they are calling private APIs of this application, as opposed to operations and when there's a call from one application to the other. So that's important if you want to maintain invariant. So for instance, for the equivalent of the ERC20 application, we'd like a possible invariant would be that we don't want to mint coins. And so the fact that you can, so we'll see in a minute that's important, that the messages are internal and they cannot be created out of thin air, for instance. And here we go. Here is the equivalent of ERC20 application. So imagine that so this application in this case, we start simple with only one user per chain. So the state of the application will be a single number, which is the balance, the number of tokens that are currently stored on a particular macro chain. And of course, the application has potentially a number for every macro chain in the system, right? So now, if I execute in this simple application, we could say there's only one operation, which is to transfer a certain amount from the current chain to a target chain. And so when you execute this operation, it's going to burn the given amount, so deduce it from the local balance, and then it's going to create a message. And there's also only one kind of message in this case, which is a credit. A credit message will inform the receiver chain that they are allowed to mint that much tokens, that many tokens. And so in this case as well, so the operation can be created in a block, but it's also the same thing if one application wants to call another application, then it would be also just a transfer operation. Just the same. It's the same public API for composing and for calling from a block. Okay, so so this example has a single number as the state of the chain, and that's okay for single user chains. But of course, in full generality, the chains could belong to several owners. So you could imagine that a chain has been configured so that several users can produce blocks. And that would be useful for options, for instance, or for atomic swaps. So in that scenario, we'd like the equivalent of the ERC20 applications to be able to would be able to hold the balance of several users. And we'll have to talk about this in a second. What it means. So now, in terms of BFT consensus protocol, when you have several owners, as I was mentioning earlier, there's one more round than usual. At least one more round than in the best case scenario. And then there are also cases where we prefer to have a leader rotation between all the owners. So that would be kind of a fallback mode that is currently implemented, and it's still a bit experimental, but will be developed later. Will be documented later. So Okay, so now so enough with the BFT, the details of the BFT protocol. So let's look into what it means to have several owners sharing a chain. So for the ERC20 app, what the state would look like is you have a number of balances. So you have a ledger, like a map from addresses to the balance of an owner. And now when you want to execute a transaction to transfer coins, you would specify what is the source address, the amount, the target chain, and the target address. Okay, and now the message is going to be a credit message, and this time the credit message has also the target address. So um, and now in terms of authentication, when we don't want to allow any block to execute a transfer from any address, we will verify that the source address of the operation is the same address that signed the block, is the same user that signed the block. Interestingly, in Linera, users don't sign transactions; they sign the blocks that contain the transactions. But other than that, it's the same. It's very similar to usual Ethereum transactions. Okay. Um, Something also to notice is that we have a notion of authentication that can be carried by messages. So you could imagine that there's a withdraw message that asks to withdraw a certain amount of tokens from the receiver chain if it is accepted. And but that message would have to be obviously authenticated by the owner of the address, of the remote address, and that's also supported in the that's already supported in the SDK. Um, all right, so I mentioned earlier so that messages must be accepted by receivers. They can also be rejected, and that is necessary if, for instance, there's not enough gas to execute the message. And so when your application declares that it wants to send the message, then the the um, the message can be declared as tracked. When that's the case, but you're requiring that in case of rejection, the message is going to be bounced back to you. This is important because if you send an asset in a message, uh, if the message fails to be executed because by lack of gas, you don't want the asset to be lost. You want to, in fact, be given the asset back to you. So, and in general, so you when a transaction creates is calling into an application, and then that application calls into another application, and let's say you both calls are creating messages. What's going to happen is that we are going to deliver the messages in the order they were created um, to the receiver. If they are intended for the same chain, we will order them. We will deliver in the same order, and the vision is also they will be ordered atomically. So if a message is accepted by the receiver, all the messages that have been created by the same transaction in the same chain also are accepted. And why would we want to? What does it matter? There's a pattern that we've seen in the examples that is very convenient and to know, very important to have in mind. So so you have the ERC20 application that we call the equivalent of the ERC20 application that we call fungible. This app is called all the time by higher level applications that wants to move assets around. And so let's say that you want to create a crowdfunding application. So the you have so this picture is going to let's describe how I can make a pledge of a certain number of assets to a crowdfunding instance that is currently running on another chain that is called Wine. So the way that would happen is I create a new block, and this block is going to call into the crowdfunding application that I have locally, telling the application, okay, I want to make a pledge and in tokens. So this application, the crowdfunding, is going to do a number of things. So first, it's going to call into Fungible and say, okay, I have a number of assets locally. I need to move them on the chain of the campaign, of the crowdfunding campaign. And that's the message M1 on the diagram. And then, but that, so that is moving the assets to the other place. It's not changing the ownership. And also the receiving chain still doesn't know what to do with the assets. So after creating a message M1, the crowdfunding app is going to create another message M2 that says, okay, and by the way, the assets that I just moved, they are intended for to make a pledge. So please, can you change their ownership and assign these tokens to the campaign application on the chain Y? And can you also remember that I was the one that was pledging those assets, so that if the crowdfunding campaign is not successful, I want to get my money back. And so that's the meaning of the message M2. So it's very common that in Linera you create several messages in the same transaction, and some of the messages come from one app, and others come from another app that was called by the first one. And that happens for every time you want to pledge assets or you want to bid assets. So we in our examples for AMMs and order book, that's also the case. All right. Um, so yeah, so on a philosophical level, I mean, on a high level, I was saying that operations are public APIs, and so are application calls. And in fact, they are now the same thing in the code base. In the future, we also are thinking about having a notion of script. So if you could have a transaction that tell the block execution, hey, I want to call application one, and I want the result to be fed into the transaction into a call to application two. That's not covered yet, but it will be. All right, so this was the programming model and the execution model for transactions. Now I'm going to talk about a very interesting feature of Linera that we call the service part of the application. So far, everything I was mentioning was for the traditional smart contract executing transactions. So we call that part the contract bytecode of the application. But there is also a second part to a Linera application, which is called the service. The idea is that the contract has to be metered and can mutate the state of the application. And the service part is not metered and can happen anytime and is only accessing the application state in read-only. And why is it useful? Well, it's useful because now since so we're going to in Linera, the local wallet, the goal of Linera, if you remember the picture a few slides before, in Linera, we like having our wallets replicate the state of their chain. And so now, since I have the state of my chain in my wallet, I might as well so it means I have the local and I've executed, so I have the local on-chain data in my wallet. So we might as well allow the web UIs to query this data and so that they can populate the different fields. So if I'm looking at the payment application, the UI of that payment application should be able to easily tell me my balance. And for that, let's just query the local wallet because it has the data. And so the way it works in Linera, so the web UI can query the system in GraphQL, and then each application can be queried in the particular service of the application can be queried in JSON or in GraphQL directly, and that query will be processed by the service part of an application. So what's nice about this is that now you have a system where basically the wallet is acting as a local data provider that is trusted because you are running it yourself in your web browser, for instance, or in an extension of the web browser, so it's trusted by definition. And the code that is computing the answers of a particular query is also trusted. It's been written by the author of the application, the same author as the smart contract itself. So when you get an answer, you can the application that is connected to the local wallet knows that this answer is actually secure. Um, and you know that, then you don't need to any cryptography to tell you that, um, as opposed to in some other systems where you have Litecoin, for instance, that would be used to verify authenticated answers coming from data providers. And so here, because you have a local provider, you don't need any complex cryptography to authenticate the answers, and that gives a lot of freedom to the developer. Um, um, Another thing, there's no restriction in the kind of queries and the kind of answer you can get from the service application. Another thing that is nice is that about this setup is that the now the web UIs can also request mutations, so they can call into the local wallet and saying, "Hey, I'd like to talk to the Fungible app and initiate a transfer." And to do that, it's just another kind of GraphQL query that we call mutation. And of course, the local wallet is going. So the local wallet will then create a block that contains the transactions to implement the intention in the GraphQL mutation. And before signing the block, the local wallet should of course ask for permission to the user. Um, all right, so. Uh, oh, okay. Here we go. Okay, so the big picture is, if we put everything together, we have validators on the left side, and we have the user wallet and the web UI on the right side, and so you have ways to create blocks and push them to extend the chain, and then importantly, you also have ways to maintain a connection with the validators. So the wallet can maintain a connection with the validators and receive notifications. And the wallet can also push notifications to the web UI. And so suddenly, natively in Linera, we have this possibility to for reactive UIs. Okay, so suddenly web UIs can, if I receive a message, the web UI can be notified um, in near real time, and then ask for, okay, I received the message. So what does it mean? What is the message? And you can act on it, and you can update the balance. For instance, if you were at the payment application. And so that's one of the features of Linera that is really cool, is really the ability to, when you create a transaction, not only to get a very fast response for the system telling you that your transaction is finalized, but also immediately notifying users that might be interested in the outcome of this transaction, and notifying their wallet, and then refreshing the UI of the users on the other end. And in this picture, there's no latency induced by any data indexing or any external third-party provider. Okay, just one last word. And so some other features we're pretty excited that are being worked out. So user blobs that will allow publishing any content, any blob of reasonable size to the validators, and then obtaining a handle in the form of a hash that can be used by transactions. Then when it comes to interactions between chains, we're also working. So we already have a system to broadcast messages from one chain to a number of subscribers. And in the future, we'll make that more scalable using the notion of data streams. That will allow that's very similar to indexing events in other systems, except now we can create a stream of events on every microchain, and have the events consumed by the other microchains internally to the system. So that's something that's very very interesting for social applications. If you have a news feed, you will be able to create a data stream of posts that can be consumed by subscribers. So we have a demo on this right now, and this is going to be optimized later on with this new concept of data stream, making it way more efficient. Okay, so last, let's look into a few more example applications. Some of them linked with the hackathon, so some of them are interesting to discuss for some of the prices. So how to create games in Linera. So in Linera, typically, you could create a game you would like to, if you were to have a chess game, you like this a game instance to run in a new microchain so that uh, you have infinite scalability. Like any number of people can play a game separately, and each of them is working their own block space in parallel. Um, and the nice thing is that you can even and so that temporary chain corresponding to the chess game would have two owners, potentially also a referee if there is a notion of time, and would be able to accept blocks by the two owners alternatively. Okay, and atomic swaps. So we don't have an example or we're working on an example of a multiplayer game that's going to be available very soon. But in the meantime, there's an example of atomic swap that is relatively similar and can be used as inspiration. Atomic swaps actually work relatively with also with the temporary chain, where you so one of the initiator of the swap will create this temporary chain, then will lock their asset on the chain and and explain what they are expecting in return, and then the other user will lock the counterpart and confirm what they want also in return, and then a user can create the last block to confirm or cancel the operation. Okay, and now when it comes to AI, so one thing that's very interesting with microchain is that when the transactions run um, in their own chains of block, they can take time, and the other users are not affected by heavy transactions. So we have a very so we are really interested in supporting AI and different sorts of oracles in the future in the macro chains. So for now, our demo is not using AI, is not doing AI inference in transactions, but it's doing it in a service, and that's what this picture is describing. So you in this picture, you imagine that you have an AI model that has been deployed in the service part of an application, and now you can just query it because this part is not metered and does not try to be data. It doesn't need to be deterministic. You can safely query out of the box in the Linera protocol. You can safely run AI inference and let the web UIs query in JSON the machine learning model. So we have a demo for this that is already available. And so now you may ask, okay, well, what's the point of calling AI models off chain? And so the point would be that, for instance, so the description of the model itself can still be made on chain. And plus, if you add, for instance, a notion of prompt, you could also store it on chain, and that gives you an interesting form of NFTs where the prompt you can own a prompt, and when you want to visualize the prompt, you use the off-chain, use the service part of an application to visualize the prompt by generating the image that is described by the prompt. Okay. So we covered a lot. So if you made it so far, congratulations. And it's time just to wish you happy hacking. And the hackathon is starting. Is just starting today. We'll also add some content progressively. A few more, perhaps a couple of demo apps, more content in the Linera dev manual, and you can also watch. We're gonna add videos, YouTube videos also, so you can find us on our YouTube channel, and we'll be happy to help on Discord as well.
Matthew. I will now present some slides and I'll go over the program specifics. And Matthew, I'll take you off screen and I'll bring you back for the end when we say goodbye.
Sounds good.
Thank you.
Sounds
Thank
good.
you. Okay, great. So thank you everyone for being here. We're really excited to kick off this hackathon. So for my portion of the presentation, I'm going to dive a little bit deeper into the specifics of the hackathon and what you'll need to do to be successful and some of the resources that we have available. So first off, I'd just like to outline in a broader sense what the program has to offer and what the opportunities are. So by participating in this program, you'll gain practical experience with the Linera SDK and Web3 programming. You'll be among the first to learn Linera's horizontally scalable architecture, participate in live events and workshops like this. We'll also be hosting some technical workshops, and build a Web3 application that is posted on the Linera Devnet. And of course, also have a chance to win from our prize pool of $12,000. But here's the calendar of events for the program. This is going to be published on the schedule tab on DevPost, along with the links to the Crowdcast events. So far, this includes the kickoff and 3 coding workshops. However, I'd recommend taking a look at this periodically, just in case we decide to add any more programming based on the feedback that we received from you guys during the course of the program. So make sure to look out on Twitter, Discord, and Telegram as well for any other updates on this. For your submission, you must build a Web3 application that is built on the Linera SDK, written in the Rust programming language, and deployed on the Linera DevNet. So the most important things to submit are a URL to a public code repository where the code is open source, as well as a 3 to 5 minute demo video explaining what you guys have submitted. The main resource that you guys will be using for your submission is the developer documentation that is at linera.dev. This includes a comprehensive guide to Linera, and it'll get you started with installing the Linera command line interface tool, claiming a microchain, and writing your application, and then also publishing it to the DevNet. It'll also give some background on advanced concepts, like how the Linera blockchain works. And if you want to dive even deeper, you're also welcome to read the Linera white paper on our website as well. So what can you build on Linera? Matthew went over this a little bit, but Linera is optimized for Web3 applications that require processing high volumes of time-sensitive transactions created by many users in parallel. So at the time of this presentation, we don't yet have a testnet, mainnet, or token. And given the current state of the project, we recommend building an application that incorporates some of the following features, which is payments and messaging, publishing social content on chain, auction systems, on-chain games, AI assistants, autonomous agents, and then also publishing software and running sandbox code. We've also created a few demo applications, so you can view that on our GitHub at linera.io/demoapps. This link is also shared in the resources section on DevPost. We have more than 4 example applications with more incoming, but here are just 4 examples to give you guys an idea. And here you can also see an LLM that runs a large language model in there, a fungible token that demonstrates cross-chain messages, and a social app where users can subscribe to other users that make text-based posts, as well as a crowdfunding app that uses the token from the fungible application. And if you need even more inspiration, you can check out some of the projects submitted during our developer summer school that was hosted on DevPost as well. We had a range of high-quality submissions across multiple different domains. The top 3 winners were ResPeer, a peer-to-peer content publishing application, Equalizer, a revenue-based financing protocol, as well as Linera Logger, which is a tool that explores the Linera network with transactionless block inspections and metrics. So I welcome all of you guys to check out some of the Linera Developer Summer School projects on DevPost for some inspiration. I'd also highly recommend checking out some of the previous coding workshops held during our previous hackathons on our YouTube channel. So there's 2 playlists. There's one for the summer hackathon, and then also one for the autumn hackathon, the autumn hackathon being the most recent one. They're still a really useful resource, and our future coding workshops for this session will be based off of these with added updates and improvements for the Linera DevNet. And we'll also be introducing some new content that wasn't covered in the previous hackathons. And in terms of the prize pool breakdown, there's going to be 6 prizes in total, which includes a prize for first place and second place for 3 different prize tracks. The three prize tracks are for the best consumer facing application, the best gaming application, and the best AI application. The total prize pool will add up to 12,000 US dollars, and the winners will be up to the discretion of the judges. Also, in previous hackathons, we've added additional prizes throughout the hackathon, so also be sure to continue to keep an eye out for this in case we add some more prizes. The criteria that will be used to judge your application will be technological implementation for 40%, design for 20%, potential impact for 20%, and the idea quality for the final 20%. And all 4 of these categories are given a rating out of 5. All the judges are members of the Linera team, including myself and Matthew, as well as Christos, who will be running the technical workshops. So here's our Twitter, Telegram, and our Discord. If you guys would like to join our community and stay up to date with the Linera ecosystem, I'd definitely highly recommend joining the Discord channel and specifically the Linera Spring Hackathon 2024 channel for any technical questions that you might have. Thanks, guys. I'm looking forward to seeing what you guys build. And yeah, we're very excited to host you guys for this hackathon. Perfect. So I got Matthew up here.
Thank you.
Thank you, guys.
Thank you, everybody.
See everybody.
And good luck.
We'll see you at the technical workshop next week. Cheers.